Hello, everybody. It is Miss Lloyd. We are looking at exponential and logarithmic equations and solving them. So whenever we're solving some simple equations, one of our main goals, well, when we're solving any equation, is to get our x value alone. And so in order to do this, either we need to get the exponential part or the logarithmic part alone first. If we have more than one log, that's when it can be a little bit tricky, and we want to simplify everything to one log on each side and use the one-to-one function property. I meant property. So then here we already have our base with the exponent alone. And so in order to get the x out of the exponent or no longer being the exponent is to get rid of our base. So I'm going to take the log of our base of 2 to both sides. Log base 2 and big base 2 cancel out. And then in my calculator, I can plug in a log base 2 of 512. And when I do that, I end up with 9. So 2 to the 9th power is 512. Who would have thought? My next one, the logarithm is already alone. There's nothing adding or subtracting with it, nothing multiplying or dividing. And so now I need to get rid of that log in order to get the x by itself. And so because it's a log base 6, I'm going to base 6 both sides. The log base 6 and the big base 6 will cancel out, leaving me with x being equal to 6 to the 3rd power. And 6 to the 3rd power is 216. And we're done. The next one I want to look at, I do have something aside from just my e to the x power on the left side. So what I want to do is get rid of that 5 first. I also don't want the negative in front of my e, so I'm going to divide everything by -1. Now that the e to the x is completely alone, I can get rid of the e itself. So in order to get rid of a base, I need to take it to the log of that base. And of course, a log base e is just an ln. The log base e and the big base e will cancel out, leaving me with x is equal to the natural log of 5, which we can plug into our calculators, and we would end up getting 1.61. Next, there are a multitude of ways to doing this. For this next one, I'm a little bit bored and I want to have a little bit more fun. And I also know that my 9 and my 3 can end up being the same base because 9 is 3 squared. So I'm going to change that 9 into 3 squared. And in order to get the 3 out of the denominator, it's going to change into 3 to the negative first. Because my bases are the same, then my exponents must also be the same. And so my x ends up being equal to -1/2. Wasn't that a hoot and a half? I think so. And then I'm going to do these next 4 with you guys, and there's an entire other page of examples that I'm going to do with my students. So here they want us to solve each equation and then approximate the result to 3 decimal places, which means we're likely going to want our calculators handy. So for this first one, my e's are already alone. There's nothing on the outside of my e bases, and because these bases are the same, that means that the exponents must also be the same. So my e's are virtually useless at this point in time. And I see I have an x squared, which means I'm likely going to have to do some factoring. So I'm going to move my 2x to the other side to get this equal to 0. And I want to make sure that my x squared stays positive. Now that I have a trinomial, I'm going to use my m and a in order to factor. And so numbers that multiply to give me -8 and add to give me -2 are going to be -4 and +2. Which means my factors are going to be x minus 4 and x plus 2. And last, I'm going to set these equal to 0 because of the multiplicative property of 0. And I end up with 2 solutions, one being 4 and the other one being -2. For our next problem, we have a little bit more than just the 5x. And so I want to get that 5 to the power of x completely alone. So I'm going to divide this 2 over first. And now that my base and its exponent are alone, I want to get rid of that base so that the exponent becomes just a regular, like its own base. In order to get rid of a base of 5, I'm going to do log base 5 to both sides. Log base 5 and big base 5 cancel each other out. And in my calculator, I can plug in the log base 5 of 16, and I would end up with 1.723. Next one, I have a 7 that is with my e to the power of x, and so I need to move that 7 to the other side. Now that the e is alone, I need to get rid of it, and in order to get rid of a base of e, I need to do a log base e, which is pretty much just a natural log or an ln. The log base e and the big base e cancel each other out. So in my calculator, I'm plugging in the natural log of 30, which is going to give us 3.40. I hope you found this helpful. If you did, please like and subscribe. If you know of someone who this could help, then please feel free to share it. Spread the love.